Today we're looking at rotation of vectors applied to parallelograms. So if you have, let's say, the origin there, and you have a point here, let's call it A. And let's say this point is 6, 2, argument's sake. So there's your point there, which is also a vector. If you were to rotate that 90 degrees, and let me say, in this case, clockwise to get to this point here, and let's call that point B. B then, according to our theory that we've done before, is just going to be equal to 6 plus 2i multiplied by minus I. Because rotate by 90 degrees clockwise is just simply multiplied by minus I. So that's how you find B, by the way. So if they ask you, they give you A, and they ask you for B, then you simply multiply A by negative I, and you get B. And the answer here is 2 minus 6i. That's a very quick way of doing that. But if you go to your extension 1 vectors, then it's like the same thing, because this is how you do it, extension 1 vector style. So you go, that's 6, that's 2. So what you do is you reflect this. So 6 then becomes minus 6, and 2 then becomes 2, reflected out there. So that means there's a vector there, 90 degrees. That's a fast way of doing that, using 3-unit vector style. But that's on the side, right? Now, first question is find B. Second question is find the point C such that OACB forms a square. So C, you can see then is over here somewhere. Yeah? So how do you find the point C? Well, here is one property of square or parallelogram that you learn in the junior years. Think about square or parallelograms is that the diagonals of the square parallelogram meet at the same point. So the midpoints are the same. And that's what we're going to apply here to find out the point C in this case. So you're going to go that way, you're going to go that way, you're going to join that up, you're going to join that up. So in other words, the midpoint of OC is the same as the midpoint of AB. And then you use Maths Advanced theory to work out the point C. Very easy by doing that. So let me call this point A, comma C. So that means the midpoint of OC is just A over 2, C over 2. And the midpoint of AB, because you have A and B, is just that added together. So 6 plus 2 is 8. 8 divided by 2 is 4. And then minus 6 plus 2 is minus 4. Minus 4 divided is minus 2. So in other words, A on 2 equals 4. So A equals 8. C on 2 equals minus 2. So C equals minus 4. So in other words, the point C is 8 minus 4. In complex number form, it's 8 minus 4i. There is your C in a very quick way. So recap. If they give you the point A, and they ask you to find the point B, being A rotated 90 degrees anticlockwise, then you multiply by minus I. But if they ask you to find the point C and even B, such that OACB has to be the order here, forms a square, then you find B first, and you find C by finding the midpoint. That's how you find the points B and C, given the point A only, such that OACB forms a square. Now, the order is very important here. I said OACB because if they ask slightly different and say, find the points B and C, such that O, comma A, comma C, comma B, form a square, then you can have other points possible. You can go rotate at 90 degrees to get over there to get B, and C is over there. So that's another combination. But in this case, if they say OACB in that order, then B and C must be over there exactly. And that's why I'll stop.